So I'm Rob Gielen from a company named Robovision. We're a Belgium-based company. I'll give a presentation on what we have been doing in the last decades and how it could be relevant for you. Let me see if the presentation
There you go.
can get
right?
up and running. Okay,
Yeah.
we're good to go. Indeed. So here I am, Rob Gielen, Market Director at Robovision. We're a Belgium-based company with around 100 people, and we are all about scaling vision AI in AgTech robotics. So what are we? So we're a software company in a hardware world. So we have been developing on a Robovision AI platform, which is a platform that helps OEM machine builders to integrate advanced AI into their smart automation offering. We have been doing that for over a decade already, and are working now on our 5th generation of software platform. And we have a team of over 150 people. But our North Star metric is really helping our OEM customers to develop AI-based machinery and put them into deployments. So we're very proud to claim that we have more than 1,000 machinery running in the world, running production. 70 to 80% of them is in the AgTech space. We're born and raised in horticulture, and here we have tons of machines deployed all over the world. Our first success was the picking robots already like 10 years ago, of which we sold hundreds of, still today a monopoly. We're also pruning roses, looking into roses in 3D and detecting where to cut and how to cut them. We're planting and sorting tulip bulbs and also harvesting tomatoes. More on that later on. We're born and raised in horticulture, but in the last couple of years we have been taking steps into other industries as well. We're now partnering up with leading OEM companies in industries like semicon, food sorting, and the biotech industry. And we help them create AI-based machinery to sell that to their customers, being the big boys all over the world, among them Syngenta, PepsiCo, Driscoll's, TSMC or Intel. As I said, we're a software company, but we operate in a hardware world. In the land of vision AI, you always have a physical item. You always have a camera, and typically you always have a GPU and a robot and an end effector. Right? So here are some of our partnerships where we collaborate with biotech companies to create cutting robots in the biotech industry, or with Hitachi High-Tech with their $8 million electron microscope, where our software does the AI-based defect classification. And the cool thing here is that we integrate with incumbent OEM companies so that they can add new features into their machinery. And it's their end customers and domain experts, very often, that are enabled to train their neural nets. For example, in the Hitachi example, they have customers like TSMC and Intel. It's their quality managers in Taiwan that are currently logged into Robovision AI and retrain a new neural net to add a new defect class of semicon defects. So I'm here to talk about the big opportunity that is super obvious, the opportunity of AI in robotics, but it's also a land of inflated opportunities, right? We have been seeing that although all the consultants are claiming big futures for AI and robotics, it's very hard to scale. Those same consultants will give you also a lot of reasons why it is not working and high failure rates. We see also here that a lot of companies that were here last year aren't here today anymore. Why? They really have difficulties of getting into production and scaling into production. Even if you have unlimited cash, it's very hard, right? Even Elon is struggling with getting full self-driving, scalability into production. Yeah, it's really a hurdle to get this up and running. Also, we learned it the hard way, right? So over 10 years ago, we were developing robots with very simple setups, with some open source vision components that were available. So we really learned it the hard way. So what are the lessons that we've learned? First of all, in Vision AI, right? It's very hard to train your first neural net. Very simple, sorry, to train your first neural nets in a proof of concept setup. You basically just configure a data set, you label it, and you link it with an open source algorithm, and you will get to that 80% quite quickly. A lot of startups and scale-ups are proof of concept ready today, but there's a lot of hidden technical depth when you scale out. Lesson number 2 is mainly in agriculture. A big hurdle is nature's variability, right? You have continuously changing environments, you have continuously changing plant types, and you have a continuous thirst of doing it better than yesterday. So what's calls for that is that you continuously need to give your AI models a bit of love so they can adapt when environment changes, or they get better over time. And out of that frustration that we've seen in the last 10 to 15 years, we've developed Robovision AI, an end-to-end vision AI platform that enables OEM companies to create, deploy, and manage deep learning models at scale. So what happens if you integrate Robovision AI? So you have an end-to-end platform in which you can manage your changing AI models in a simple workflow. And very important, for every model that we get into production, we can monitor those models into production and set up continuous improvement loops. So it's really as simple as getting your data, importing them, labeling that data, depending on the model that you want to create. It can be segmentation models, it can be object detection models, and other types. We have all the tools available for that. Also predictive labeling or large vision models. Assisted labeling is something that we offer. Next step is you train your neural nets, right? You do run all sorts of experiments in this image right here. You have different models that you're training next to each other, and see all the training parameters that you're using. And lastly, you're testing your AI models to see against the golden data sets, what are the AI models that perform the best, and that is the one that you will push into deployments. Like I said, that's the easy part, right? Training your MVP AI model. From that point on, you deploy into inference. You're running your model on an edge device, in your robot, in your machine. And from that point on, the hard part starts, because you want to continuously monitor the accuracy of your model into production and set yourself up for continuous improvement loops. Gather those data points, those images of plants, of defects, of whatever, that have a high likelihood of significantly increasing your model, and only storing those and setting them up in your as a new data set. So your domain expert, your farmer, your integrator, the OEM, depends on the business case who does what, can retrain and again redeploy. And it's really a very universal AI challenge, but if we look at the team of Tesla, here the director of Vision AI, Andrej Karpathy, in one tweet in 2022, basically on a napkin defines or reassures our business model as a universal AI challenge of creating data, boosting that data, labeling that data, retraining that data. And his claim was, it's not about the data itself, it's about having an engine and your boots on the ground of continuous gathering new data, continuously retraining your model so you can redeploy. So we have been developing on this for over a decade, and have been integrating that into many customer cases. Like I said, so we're running in the biotech industry, like also for companies like Driscoll's in the tissue culture, to have a 2D robot that detects very small parts of plants, picks them up and plants them into Petri dishes and these type of liquids filled pots. Other use cases, like I explained, is more complex, more in 3D. So here we look in 3D to rows, branches, detect where the main stem is, where the branching points are, and depending on the 3D point clouds, know how to steer the robots into the right direction for the cutting parts. We're also active in the outdoor ag with drone-based use cases for drone-based phenotyping to detect very small plants, to count these plants, to do ripeness classifications, and so on. Typically, as this is an example, is how our software is integrated into a broader software where crop monitoring is being done, and there very performant and highly accurate AI models are just a part of a bigger scheme. Like it is also the case in the robotics space. This is one of our latest developments on which we have been developing for many years already with our incumbent TTA ISO, who's the biggest robotics company in indoor agriculture, with whom we are developing a tomato harvesting solution that is now in the pilot phase and is deployed in their first customers. And we were going for full commercial launch later this year as the first company worldwide to do it. If you look at these type of applications, we see that labeling is a very big hurdle because it's a 3D space of a wall of green with leaves, with branches, with strings and so on. It took 20 minutes to label one image and you need hundreds of thousands of them. So it's very costly. And with a lot of powerful tools that we have, we sped up this between 8 and 10-fold using predictive labeling and large vision model assisted labeling. And that has made it possible for us to develop these tomato harvesting robots using semantic segmentation on deep stereo depth maps to know the cut targets and to do ripeness classification on very accurate goals. So these are some of the customer cases that we have been doing. I repeat that our business model is really to help OEM machinery companies to develop these type of robotics and to scale them. We've been around, we've been there, done that in many occasions. So if among you there are companies that are now at pilot phase, at proof of concept phase, and are dreading like scaling up to hundreds, thousands of machines in all time zones, please reach out. I'm sure we can help you, at least give you a word of advice. Thank you.